Next is the liquids for our states of matter. And liquids and gases, both of these particles are going to be in motion. They're going to be free to slide past one another. So this means they have the ability to flow. So liquids and gases can both go in the category of a fluid. So if you've ever filled up a gas can, you can kind of see the fumes from the gas flowing over the edge of the gas can, or steam flowing over the edge of a boiling pot of water. Liquids, particles are going to be attracted to one another, which is going to make them more dense than gases at STP. And this is because of those intermolecular forces, your hydrogen bonding, your van der Waals forces, pulling those molecules closer together. And so that's going to make them kind of clump up and form a liquid. Liquids we're going to consider non-compressible. They are compressible to a degree, but under normal circumstances, we would just consider them non-compressible. So going from a liquid to a gas or a vapor, vaporization is the general term for any time a liquid becomes a gas or a vapor. Evaporation is specific to if the liquid is not boiling. So a mud puddle on a warm day is evaporating. You boiling a pot of water, that is vaporization. So vaporization is going to occur faster with a heated liquid. So a mud puddle is going to evaporate or vaporize quicker on a 90-degree day than on a 50-degree day. And that's because of the increased kinetic energy of the particles. Those particles want out. Okay, vaporization is a cooling process, so your temperature is actually going to decrease because those particles with the highest kinetic energy are going to want out and they're going to escape first. So when those high energy particles escape, the temperature starts to go down. When you have a closed container that is partially filled, some of those particles are going to vaporize. So I want you to imagine a partially filled water bottle that's been sitting in your car on a rather warm day. So as those particles vaporize, they start to collide with the container walls. And remember, collisions are what build up a pressure. So you're going to get a vapor pressure at the top of the bottle or above the liquid. And as that vapor pressure increases, those particles are going to be pushed back together into their liquid form, so you're going to get condensation occurring. So when you go from a liquid to a gas or a vapor, that is vaporization, and gas back to a liquid is condensation. You'll also notice condensation forming on a glass of ice water on a warm day. Boiling is when your vapor pressure equals the external pressure. That is when you reach the boiling point. And again, boiling is going to be a cooling process. The temperature of a boiling liquid is never going to go above its boiling point. The only thing you're going to do is make it boil faster. So water boils at 100 degrees Celsius. No matter how hot your heat source is, the water is never going to get above 100 degrees Celsius.